A gas turbine is supplied with a gas at 5 bar and 1000 Kelvin and expands it adiabatically to 1 bar. For the gas, take Cp is equal to 1.042 kilojoule per kg Kelvin and Cv is equal to 0.766 kilojoule per kg Kelvin. It is a linked data question. It consists two questions and the second question answer depends on first question answer. So here first question is the exhaust gas temperature is. Options are 392.5 Kelvin, 447.2 Kelvin, 596.6 Kelvin, 653.2 Kelvin. And the second question is if the mean specific heat at constant pressure is 1.0425 kilojoule per kg Kelvin, then the power developed by the turbine in kilowatt per kg of gas is. And here the options are 212.42 and kilowatt per kg, 361.5 kilowatt per kg, 492.51 kilowatt per kg, 552.26 kilowatt per kg. Here coming to the solution, the given data is we know that the entrance temperature of the gas is, and first let us draw TS diagram for gas turbine power plant. Let us say so here it is Brayton cycle on TS coordinates. Here 1 to 2 is compression, 2 to 3 is heat addition, and 3 to 4 is expansion, and 4 to 1 is heat rejection. Here 3 to 4 is expansion which occurs in turbine. So here we know that the entrance temperature of the turbine, that is T3, is given by 1000 Kelvin, and we know that Cp is equal 1.042 kilojoule per kg Kelvin and Cv is given by 0.766 kilojoule per kg Kelvin. So that here the ratio of specific heats which is indicated by gamma or N and is given by Cp by Cv and is equal to 1.36. So here it expands adiabatically from 3 to 4. So we know that the pressures at 3 and 4, that is P3 is given by 5 bar and P4 is given by 1 bar. So that we have a relation between temperature ratio and pressure ratio in adiabatic process, that is T3 by T4 is equal P3 by P4 power of gamma minus 1 by gamma, and which implies here T3 is known value, that is 1000 Kelvin, and T4 is unknown and we will have to calculate it, and P3 by P4 is given by 5 and gamma is 1.36, so that gamma minus 1 by gamma is given by 0.36 by 1.36. From this we can calculate T4 and which is equal to 653.2 Kelvin. So here the first question answer is 653.2 Kelvin and the option D is the correct answer. And coming to the second question, here power developed by the turbine and which is equal to work developed by the turbine. Either power developed or work developed is given by Cp into T3 minus T4, where T3 is 1000 Kelvin and where Cp here is the average specific heat of gas and which is given by 1.0425 kilojoule per kg Kelvin and T3 is equal 1000 Kelvin and T4 is 653.2 Kelvin. So here the final answer is the power is given by 361.5 kilojoule per kg per second or 361.5 kilowatt per kg. So here the second question answer is 361.5 kilowatt per kg and the option B is the correct answer. The arc length voltage characteristic of a DC arc is given by the equation 24 plus 4L, where V is the arc voltage and L is the arc length in mm. The static voltage, the static volt ampere characteristic of the power source is approximated by a straight line with no load voltage of 80 volts and short circuit current of 600 amperes. It is a linked data answer question. It consists two questions such that second question answer depends on the first question answer. So let us see. First question is the optimum arc length is, and the options are 6 mm, 4 mm, 3 mm and 2 mm. And coming to the second question, the power factor is, options are 0.8, 0.6, 0.75 and 0.5. Coming to the solution, we can write the source characteristics of the power can be written analytically as the power source characteristic can be written analytically as V is equal to 80 minus 80 by 600 into I. They are in volts. Where here 80 is the no load voltage. That means open circuit voltage of 80 volts, and here 600 represents the short circuit current of 600 amperes, and the arc characteristics is given as V is equal to 24 plus 4L. So here let us say these two equations are 1 and 2. So now equate these 1 and 2. By equating 1 and 2, we get here I is I in terms of characteristic length, that is, so first equate 80 minus 80 by 600 I, which is equal to 24 plus 4L. So that here I in terms of L, we can write it as 56 minus 4L into 600 by 80. But we know that the power formula, that is equal to V into I, and which is equal to 24 plus 4L into 56 minus 4L 600 by 80. See here we will have to calculate the optimum characteristic length. So optimum characteristic length is can be obtained from the maximum power formula. So, but here the maximum power can be obtained by differentiating the power with respect to the length. Let us say dp by dl and equate it to 0. So here dp by dl is given by 4 into 56 minus 4l plus minus 4 into 24 plus 4l and equate it to 0, so that here we can get value of L and which is equal to 4 mm. Now substitute this value in the arc characteristic formula, that is V is equal 24 plus 4L, so which is equal to 40 volts. So here L is nothing but the optimum characteristic length, and this is the first question answer, and the correct option is B. That is the first question answer is B. And coming to the second question, it is we will have to calculate the power factor. The power factor is given by ratio of arc voltage to open circuit voltage. So here arc voltage we know that is 40 and open circuit voltage is given as 80. So that the power factor is given by 0.5, and in the option the correct option is D.